In this video, let us see how we can implement a Boolean expression using demultiplexer. Depending on the number of select lines of a demultiplexer and the number of input variables, we can have two cases. Case 1 is when the number of select lines of a demultiplexer is equal to number of input variables in the given problem. And case 2 is when the number of select lines of a demultiplexer is not equal to number of input variables in the given problem. So let us take up an example from both the cases and see how do we solve them. Here we are asked to implement the function f of a comma b comma c, which is a summation of minterms 0, 1, 3 and 5 using 1 to 8 demultiplexer. So the first step will be to identify the number of select lines. To identify the number of select lines, we can compare the given demultiplexer with its general form. So that will be input is to output. We know that the number of input to a demultiplexer is always 1 and the number of output is 2 power n, where n is the number of select lines. So the given demultiplexer is 1 is to 8, which can be written as 1 is to 2 power 3, which gives us n is equal to 3 and the number of inputs will be 1 and the number of outputs is 8. By using this information, let us draw the block diagram of 1 to 8 demultiplexer. So this is the block diagram of 1 to 8 demultiplexer. You can see that you have one data input line, 8 output lines, 3 select lines and one active high enable input. Here we had 3 input variables A, B, C and 3 select lines. So the number of select lines of the demultiplexer is equal to number of input variables in the problem. So this is case 1. So when the number of input variables is equal to number of select lines of the given demultiplexer, then you can straight away go ahead and connect each of the select line to a particular input line. So here A is the MSB and C is the LSB. So let me connect S0 to C, S1 to B and S2 to A. When you do this connection, then each of the output line will represent a minterm. So Y0 will represent M0, Y1 will represent M1, Y2 will represent M2, Y3 will represent M3, Y4 will represent M4, Y5 will represent M5, Y6 will represent M6 and Y7 will represent M7. For the minterm 0, 1, 3 and 5, the output has to be 1. So the data line must contain logic 1. After connecting the data line to logic 1, the next step is to take those output lines which are given to you in the problem, that is 0, 1, 3 and 5, and connect them to a OR gate. The output of this OR gate will give you f of a comma b comma c. So this is the way how you implement the function in case the number of select lines of the demultiplexer is equal to the number of input variables. You can cross verify this if you want. So this is the input line A, B, C. So since there are 3 inputs, there will be 8 input combinations starting from 0, 0, 0 and ending at 1, 1, 1. So A is nothing but S2, B is nothing but S1 and C is nothing but S0. And this f of a comma b comma c is the output of this OR gate. When ABC is 0, it means that S2, S1, S0 is 0 since you have connected them, and this DIN line gets connected to M0. So M0 will be 1 and all others will be 0. We have seen this in the working of a demultiplexer. And the inputs to the OR gate will be 1, 0, 0 and 0. Hence the output of this OR gate will be logic 1. So in case of 0, 0, 1, D in line gets connected to Y1. So M1 is 1 and all others will be 0, and the input to this OR gate will be 0, 1, 0, 0, and the output of this OR gate will be 1. When the input is 0, 1, 0, D in is connected to M2. So M2 will be 1 and all others will be 0, and the input to this OR gate will be 0, 0, 0 and 0. So the output of this OR gate will be logic 0. So if you verify for all these input combinations, you can see that f of a comma b comma c will be 1 only for 0, 1, 3 and 5. For all other inputs, it will be 0. So this means that f of a comma b comma c is summation of min terms 0, 1, 3 and 5. This is what we were asked to implement in the problem using 1 to 8 demultiplexer. So in the next video, we will take up a problem from case 2 and see how do we solve it.